Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. In this video, we are going to see real-time use of deterministic finite automata. So deterministic finite automata are even used in your compiler. Okay, so in your C compiler, whenever we define in C, the identifiers is having some rules. So that identifiers, C identifiers, it should start with either letter or underscore. It should not start with digit. So in the compiler there is a DFA, means they have constructed. So by using that, they were checking whether the identifier that you have taken, whether it is a correct identifier or not. Okay, means if you want to declare a variable, so your variable should start with either letters or underscore. It should not start with digit. So for that we will construct a minimal DFA. Here also I am going to construct a minimal DFA that will say whether your identifier is correct or not. Okay, whether that variable is correct or not. So you know that what is going to the sigma, the input alphabet here. Since the input alphabet is going to your here letter, digit and underscore. So initial state, if it will get letter, fine, allowed, or underscore is allowed. So first symbol, that the first digit, can be either letter or underscore. So if it is getting letter underscore, then accept it. And after that, if you are getting another letter underscore digit, then also it's fine. You will again accept it. Then you can say that it is a correct variable. Okay. So letters underscore digits. So if we are getting like this, then also we will accept it. But if in the beginning the first symbol, if we are declaring as a digit, then we have to reject it. So we will go to dead state. We will go to dead state, and after getting anything, other letters, digits or underscore, this is not allowed. Okay. So this is one real-time use that I have shown you. After, if we study what mean that mule machine, mille machine, from every topic I will give you the real time, because now I have taught you some part of minimal DFA. So now you will able to get that things, that how in the compiler these things are helping. Okay, so in compiler to identify whether the variable is correctly defined or not, then you can means inside the compiler they are having the minimal DFA that will check whether your variable is correctly defined or not. Now see, so the example that we have seen, the machine deterministic finite automata, by this we can conclude that even the compiler and the other translator are going to use extensive use of that. Okay, why? Because the compiler is converting high level language to low level language. Okay, see here, the compiler and other translator that convert a program from one language to another make extensive use of the idea touched in these examples. So they are going to use extensive use. They are going to do extensive use of the idea, because whenever any conversion, any verification is required, we can construct a automata. Okay, even I have written here, automata play a fundamental role in decision processes. In decision processes, automata play a fundamental role by which a specific piece of code is accepted as satisfying the condition of a programming language. So if the condition of the programming language will satisfy, then we can accept it. So automata is going to play a very fundamental role in decision processes. Now see the real-time use of finite automata. Even that we have seen previously, it is deterministic finite automata, is also a finite automata only. So there I use deterministic finite automata just to explicitly give the real-time use of DFA. So you can even say that it is also a real-time use of FA. Okay, because DFA is also a one kind of FA only. So now see where the places where we can also use finite state machine. So finite state machine are used for parity checkers. In parity checkers we are using, okay, in vending machines. So in vending machines also we are using that. If you go in railway station, there you will see that nowadays for collecting ticket there is a vending machine. So you just type the place from where you want to go and destination, so you will get the ticket. Okay, so that in vending machines, even in IT industry you will get vending machines, even in airport. So all these are made of finite state machines. So there that we are giving the input, we are getting the output. That finite automata with output that we are using there. Okay. Even in communication protocol we are using finite state machine. Building security devices also we are using finite state machines. Now in text analysis, like when we will solve many problem, you will understood how text analysis can be done. Just like I will say that string should contain AB, that we can do by using finite state machine. It should end with AB, that the analysis we can do. And sequential circuit, in sequential circuit we are using finite state machine. Pattern matching are the application of pattern matching. You will get many problems that we are going to see, that you will get an idea how pattern matching we are going to do in finite state machines. Okay, even speech understanding system uses probabilistic finite state machines. See, probabilistic finite state machine is not in our syllabus, but you can for the sake of for real time use you can know these things, that even we can use in speech understanding in by using probabilistic finite state machine. Okay.